When you watch any documentary about our ocean and the overfishing that's happening, it's always kind of the same message. The tipping points are being crossed, there's no fish left by 2050, and we need to change now if we want to save our oceans. And so to me, it's a signal that the way that we manage our ocean is not working out as we thought it would. Basically, the whole system is slowly breaking down. But in this episode of the Creators for Climate podcast, I want to show you a story of hope and zoom in on a small country that I live in, Belgium. At our small coast, there's a team of scientists and fishers who are building a new system from the inside out. I want to take a closer look so we all get to tell what's fair and what's actually working in this new transition to a new sustainable, well, dare I say, regenerative fishery.
The more conversations I have like this, the more I realize how the ocean is sort of this big black box.
If you don't know much about what lives there and how it will be affected, well, don't fish there. First study it and then decide. The problem in general about fisheries management and fisheries science is that...
I mean, it sounds like you're really trying to kind of tackle this head on. Would that solve the problem, so to speak, of overfishing?
Sometimes all you need is 5 people of goodwill and you can move mountains.
To make this episode possible, we collaborated with the UN Ocean Decade, VISTools, the Flemish Institute of the Sea, and ILVO, the Flemish Research Institute for Agriculture, Fisheries and Food. This is also our first climate mission where we take a look at these projects and organizations that make transitions like this happen. In this interview, we're sitting down with Hans Polet, who has spent more than 3 decades in fisheries science and is a scientific director for fisheries at ILVO. He started in fishing gear technology, but is now working on the big questions. How do we fish smarter? How do we waste less? And how do we keep these coastal livelihoods, as well as the health of our ocean, as a priority? Now, before we talk about all these different fixes, maybe it's good to agree on the goal first. So to start this podcast off, what does a sustainable fishery actually look like in practice? We asked Hans to define it.
Yeah, but that's a very difficult question. You have to maintain healthy fish stocks that are large enough and have the good age composition to continue to exist and continue to produce. So it's all about the amount of fish and the intensity of fishing again. It's also about how you impact the environment. If you destroy the habitat, you destroy the livelihood of the animals living there. It's just keeping your impact low enough so that next year and in 100 years we can still eat the same amount of fish. Now, but there's also an economical side to it. Fishers, when they invest in fishing vessels and in fishing gear, they need an income. It's not only ecology, it's also economy. And there's also a social side to it, I think. There's quite a lot of issues where fishers are, let's say, pushed into bad practice or pushed into fraud by a bad management system. But also gives these people stress. I mean, I know a few fishers the last few years, when I talk to them, they say, I'll stop fishing. It's impossible. The complexity of the regulations and the impossibility of following them drives me into fraud. I cannot take this anymore as a skipper. I probably, as soon as I can, I'll stop fishing. So you have entrepreneurs that have overcome problems during centuries, and now suddenly the management system drives them out of business. I would say something wrong. I think at least we should take the initiative and the responsibility to scrutinize this, to have a look at how fisheries is managed. And I think that's a bit the point I want to make during this podcast.
As Hans said, if we want to be sustainable, we need to look beyond just the environmental side. Economy and people, they're part of that target goal too. But as I heard from talking with the fishers myself, that rulebook often pushes the whole fishing operation in the opposite direction for all 3 of those sustainable targets.
But 50 years ago, there were no rules. Everybody could fish how and how much they wanted, and it was sheer overfishing and sheer destruction. So in that situation, of course, you need a lot of control and enforcement and regulations and all kinds of measures and technical things to steer the fishery in the right direction. That took decades to decrease the fleets, to impose mesh sizes, to impose quota, and to start collecting data. So I'm grateful to the common fisheries policy that they managed to do that. So now we have, let's say, more or less a balance between the capacity of the fishing fleet and the reproductivity of the fish stocks. Now, the problem with fisheries management in the EU is that they always have stimulated innovation in fisheries, in science, and so on, but they forgot to innovate themselves. So that initial drive to regulate and to control and to enforce has not really changed. They have regulations about the fishing gear. So they can only have one fishing gear on board, which means if you are at sea for example, 10 days, and you come in a situation that is different in terms of species composition, you should use another fishing gear, but you cannot. You don't have it on board. So you have to steam back to the harbor, switch fishing gear, and then go back. That has a consequence for cost and fuel consumption and things like that. So there's a whole mixture of regulations that makes it very difficult for fishers to actually do what they should do. They used to follow the fish according to the seasons. So fish migrate, fish spawn, fish do this, fish do that, and the fishers would try to optimize the efficiency of their fishery by following the fish. And now, because of all the regulations, they cannot do that anymore. And they're kind of forced to fish in that area in that way because the regulation says so.
To me, the first thing that comes to mind is this is sort of a perfect use case for large data sets and possibly some sort of strategic implementation of AI, almost like a fish by fish level. What's going on? That's not really a question, but that's just sort of like something I'm throwing out there as like what I think of whenever I hear big problems like this.
Well, do we have something for you, Charlie?
Yeah, well, definitely data is the answer. Now, the problem is the science is good, the modeling is good, the scientists are hardworking, honest people, but the data that go into the system are just not good enough to give consistent, good advice. Put on top of that climate change, which brings changes in the ecosystem that are very hard to predict. So then the quality of the fisheries advice suffers from that.
Now, one of the things that is important here is, of course, the accountability of the fishing industry. Like I said in the intro, we have seen the documentaries of how fishing gear is destroying big stretches of nature for pure profit. And so I'm definitely not saying that the industry is holy here, not by any means. But during this project, we also sat down with some fishers to get a clear idea of how these rules and these regulations, they actually infringe on their work. And I must say, it goes pretty far, sometimes a bit too far.
Now, the way they have been doing this for these 50 years is very much focused on control and enforcement. At sea, many things happen that are just difficult to control. And if you cannot control a measure, you cannot enforce it. If you do not know what's going on, you cannot blame anybody or fine anybody. The European Commission and its control agency will be able to enforce cameras on board, not to get information for the fishers, not to get information for science, but actually to strictly follow up if the fishers are following the regulations. These complex regulations that are impossible to follow and make fishing fleets economically not viable anymore. What is the reaction of the fishers? Well, we don't want cameras. We will oppose it, and we will keep on opposing it, and we will see where it goes. And they're also saying to us as scientists, well, Hans, I'm very sorry. We like your VISTools project, and it will give very interesting information for everybody. But if we continue to cooperate with you and put cameras on board to analyze our catches for scientific purposes, it's an easy way in for the control and enforcement to actually use the technology and use it for their own purpose. So we are losing the cooperation of the fishers just because of the way fisheries management is treating the fishing industry.
It's just similar patterns that I see in Texas in the agriculture industry. There's a growing movement in the U.S. and Texas specifically with regenerative agriculture versus sort of the factory farming. There's not really a distinction from like a government standpoint, and so they're getting stricter and stricter regulations on factory farming that also apply for regenerative practices. And so you kind of see that same pattern where it's like you have these policymakers that don't really understand, or they're not sympathizing with the changes in the industry that are embraced by the farmers, and it's like a one solution crackdown sort of approach, and it's kind of ruining certain potential solutions. So that's interesting. That seems to be a pattern all over the place.
It is a pattern. I think these are nice examples for our wider society. Political decisions and management measures are often taken by people who are far from the real world. And that's a real problem. So that's why I'm doing all this effort now, because I'm convinced that the way we are dealing with things, the way we are working with fishers, and the way we are collecting data, and the potential it gives for fisheries science and for fisheries management, gives the possibility of doing things in a fundamentally different way. And I really can say in a mature way of managing fisheries, and in a way that makes fisheries really sustainable, and not just sustainable on paper or from a distance, because we know what's going on at sea, which is not the case by many other parties.
I feel like that really, I mean, it sounds like you're really trying to kind of tackle this head on, everything you just described, all of the issues with that. And so I'm really curious about what you're working on and what your team is working on.
Together with a few fishers, we developed a system that's called VISTools, and actually consists of a very simple technology in principle. We call it a concentrator, which is just a little hardware box we put on board of the fishing vessel, where you can connect any instrument that produces data. We connect, for example, the GPS to it. We connect the scale where the fish are weighed, the fuel consumption meter, the towing force in the fishing line, and in principle, anything that produces data. It started off with Pedro. Pedro is an actual fisher who has been fishing for his whole year. And a few years ago, he started connecting all kinds of instruments on his laptop. And one day he came in my office with his laptop and he showed me, look, Hans, what I have here. Look, this is Google Maps. And look here, you see our fishing vessel. And we've been fishing there. We've been catching so much. And so all this information this guy had on his laptop. And then he showed me a picture how it looked like on board. So you have this computer and all these cables and all these wires coming from everywhere connected there. We call it Pedro Spaghetti, because it actually was, it looked like a spaghetti. So, but then Pedro took the initiative to actually build a device that could be connected to all these instruments, collect the data, put them in a standard data format, and send them to the cloud and to any database that can use them. Pedro and I started working together, and soon other parties got involved, and the fishers were quite interested in seeing their own data. Up to not so long ago, the skippers on board of fishing vessels, they would record their catches just in notebooks. So the idea that all this information would be stored sounded very interesting for the fishers. And then it was up to Pedro and me and the colleagues to actually develop an interface that could visualize all this information. We did a lot of effort to make heat maps where they caught the most fish, and they could actually start analyzing this difference between day and night, difference between winter and summer, difference between different species, add fuel consumption to that. So you come to, let's say, not only gross value of the fish, but also a net value. And so it gave the fishers the ability to actually analyze their own fishery. And at the same time, this was very valuable information for us.
Now you have to understand, this is completely different from how the data is captured today. Right now, the data is low quality and low resolution, so it's really hard for scientists and policymakers to use it to set fair quotas or to manage what happens week to week. And to really see where it goes wrong now, I want to give you a few examples. First of all, most data on board is still captured in logbooks. They have to manually fill it in. So there's gonna be errors. I mean, we're humans, we make mistakes. But if you can fill it in manually, it is also open to fraud. Secondly, there's knowing what fish is being caught where. At the moment, we can see where a boat goes, but we don't know what happens during their journey. In fact, we currently only get data for what is being caught over the whole day. If you know that a single boat can sail 200 kilometers in one day, which by comparison is from Belgium to the north of the Netherlands, you can indeed ask yourself, where was that fish caught? In the morning in Belgium or in the evening in the Netherlands? And then the third issue. We have very little idea of what is being thrown back at sea. It's what we call discards. Now, to verify that data, the system uses what we call scientific observers at sea. These observers, they're only present on about 1% of the trips. 1%. That gives you a snapshot in time, but it's definitely not a full picture. And on top of that, fishers behave differently when someone is looking over their shoulder. So we can also question how correct these data actually are. So when you put all of that together, you get data that is late, it's low quality, and then that gets taken up into the system to make new regulations and new quotas. Well, it sounds pretty perfect to me. And that's where the VISTools system shows to be a real leap forward.
For example, if you compare the information we get from the scale, I told you about the weaknesses of logbook data. Now we are straight connected to the machine, to the scale where the fish is weighed. So no more errors because of the manual input, no more fraud. Every fish box that leaves the fishing vessels is weighed individually, so we will have a very high resolution. Every fishing hole, and that's on board of the Belgian vessels, 8 times a day. So instead of 1 data point a day, we have 8 data points a day. So reliable, good quality information, connected straight to the GPS. So for each fish box, we know exactly where it is caught. So all these data create the potential to actually improve science a lot. And that's what we are working on. The thing that is still lacking now is the actual detail of the catch that goes overboard. There's always a part of the catch that goes overboard. There's very few fisheries who do not produce what we call discards. So we are actually working on a camera system, and we're not alone. It happens all over the world. Many parties are doing that. Developing a camera system that films the catch that passes on the conveyor belt and analyzes the species that are present, measures the size, and maybe also other information. And we are already quite far in reaching that. So imagine, together with all the data I mentioned, we also have the full picture of the catch on board of the fishing vessel in high degree of detail. And we have this on board of every fishing vessel that participates in the program. So in Belgium, that's 37 vessels out of a total of 55. So we are a very small fishing nation. But 2/3 of our fishing fleet has a system on board and is providing the data to us. On top of that, so we're not only collecting data on the commercial fish in the catch, but also the non-commercial fish and the invertebrates and the plastics and all these things. All this information gives us a possibility to not only follow up the fish stocks, but follow up the broader ecosystem. Then we can also, what we call, implement the ecosystem approach to fisheries management, which means that we don't see the fish stock as a unit on itself, because now fisheries advise the quota are for each species and they are usually treated separately. But then by knowing how the wider ecosystem evolves, in this high degree of detail, we will be able to actually look at the position of each fish stock in the wider ecosystem, looking at the predators and looking at the prey and looking at the climate change interactions. It will also offer the tools to the fisher to actually find the high concentrations of fish, the fisher want, but also they will know much better on their sea maps where the small fish is that they want to avoid, or where the vulnerable species are, or the threatened species. So it will just add so much to the sustainability of fisheries that it's, I think, a revolution in fisheries science and in fisheries as an industry.
Because this, what you're describing, is in real time, correct?
Yeah, well, that's one of the strengths of the new system. Fisheries science is following more or less the same method, where you collect data, you have a quality check of the data, you store them in a database. The different parties that are collecting the data in the EU, that's the different member states, bring this data together in a database. Then you have working group meetings where the scientists are coming together, where they look at the data, look at the quality, analyze them through their models. Then you have a model output that comes to a first form of advice. Then that advice goes to another committee that has to, again, check the quality. Then that goes to another committee who collects all the advice of all the different species over the different areas. That combines that, then sends that to the client. In our case, that's the European Commission. In the European Commission, there's another scientific committee that scrutinizes all the information that comes in. Then the European Commission actually gets then all the formal scientific advice. And then there's no negotiations between the fisheries ministers of the different member states and the European Commission. But these things also take time. And then it still takes some time to get that into actual legislation and to the actual fishers, who then know after this 2-year period, because it takes something like 2 years, know how much fish they can take in the next year. So usually in December, we get the formal advice, the legally accepted advice, and then in January, the fishers can go fishing with that information. So that's a very slow process.
Charlie, I saw you.
I mean,
It's a lot of red tape, right?
yeah, I mean, I feel like that's kind of the classic case of a lot of things when you're dealing with government.
Maybe I just want to backtrack a little bit, because I think what is interesting here, you mentioned 2/3 of the fishing fleet in Belgium has this, right? Of course, Belgium is not like the biggest fleet in the world. Like, I think we might say that.
It's simpler for us than in other countries. I know we have a coast of 65 kilometers and 55 fishing vessels. So our life is easier than others. It's true.
There's also quite a little bit of distrust, not just with policy, but also with science itself. So, like, how do you get to so many people, so many fishermen, so many skippers having all of these sensors on board their ships? I think that is like one of the bigger roadblocks before you actually get to implement all of these systems.
Yes, that's very true. And I think that's maybe the biggest achievement. So we have this technical innovation, which is, I mean, it's not rocket science. It's just collecting data. It's not much more than that. But the real change is the social innovation. I call it social innovation now, but it's just, for me, it's just so normal and logical. If you have an issue, people talk to each other, no? So many people don't ever talk to each other. They disagree. They take important decisions that affect the other party, but they never talk about it. They never discuss it. They never question themselves. I think that's the big difference of what we've been doing in Belgium. And it actually started thanks to, let's say, NGOs and the effect they have on retailers. It was the year 2008, and I was having a meeting with a representative of the fishing industry and the most important retailer in Belgium. Well, sorry, dear fishing industry, but in 2 years' time, we will not be able to buy your fish anymore. It's not sustainable. You're fishing with an unsustainable fishing method. And, well, we are getting pressure from the NGOs, and we have decided to stop buying non-sustainable fish. It's the thing that puts the pressure on the industry, and that's how it should work, I think. And it's actually how it worked. So then we sat together. We came together with a few parties. That was the fishing industry. That was the Flemish fisheries minister. That was the fisheries administration. That was a big local NGO, a green NGO, and the fisheries scientists. we talked about the problem, and we said we came to the conclusion, why maybe should we not set up, let's say, a formal commitment to cooperation and to get mutual understanding, to build trust, and to maybe come to some more openness in all the issues around fisheries and around sustainability. Everybody thought that was a good idea. So sometimes all you need is 5 people of goodwill and you can move mountains. It took us 3 years, but in 2011, we formally signed what we call the covenant. It's a covenant on the way to more sustainable fisheries. The next step, and that I think was the most amazing thing that happened, the NGO was given the proposal to write the long-term strategy for the fishing industry to come to more sustainability. And that trajectory is, I think it's 100 pages, was formally accepted by the fishing industry. And I think this is such a beautiful thing that parties that before had difficulty sitting in the same room together, fishers and, let's say, green people, came to that agreement on a common approach for more sustainability. Now, one of the things we need, of course, is how do you follow up if the fishery is actually becoming more sustainable? So we needed a system, and we developed a science-based system we called VISTools with 12 indicators to actually score sustainability. 80% of the weight of the indicators is green, is ecological, and then the other 20% is social and economic. Now, the nice thing is that every year, every vessel owner has to come to our institute to discuss the progress of these 12 indicators, which makes that the scientists are getting some insight and understanding of the challenges that fisheries are dealing with, but also the fishers are getting some understanding about sustainability and about the problems they are causing in nature. So this is a very nice cooperation by just talking to each other, exchanging information, and coming to cooperation. And then Pedro comes with this spaghetti, and we think, well, this is the data that fisheries management have been after for 50 years, never managed to get it. Why not try to bring together a number of vessel owners that are interested in this technology, start collecting these confidential data and do things with it, and maybe use it as a way forward to make the fishery more sustainable. And that's what happened. That's how this, what I call this social innovation, actually led to these highly confidential but high quality data that are of so much value to science, fisheries, and management as well.
Is there a way to, or would it even be possible to make the data collected anonymous somehow? I mean, I know that's hard because you have the GPS data, but I'm just wondering from a trust standpoint, if the fishermen are worried about, well, you know, this data could be used against us. I'm curious if you've thought about that or if there's even a way to do that.
Definitely. No, that's a very important issue. That's a very good question. And that's the whole basis for the trust, because we have to make sure that the data that we use and the advice that we give to, for example, fisheries management, cannot be traced back to individual vessels. So we have to anonymize. We have no other choice. We can use the raw data from the fishing industry, but they stay the property of the fishers. So we do not own the data. We have it in our database. We can use it, but we have a data sharing agreement with the fishers. What we can distribute is the processed data, which cannot be traced back to the individual vessels because we throw it all together. We throw it in an artificial intelligence model, and what comes out is easy accessible, easy understandable information in maps and in tables, which has no trace anymore to the individual vessel. Yeah, but that's essential.
I love that approach of the fishermen own their own data, because I feel like that's such a relevant topic in today's world with the internet and with AI and you know, I mean, Tom and I are affected with this just being content creators, is these huge data sets being scraped and our content, our data, our creativity being swept up in that and used and then sold back to us.
That's the
Yeah.
thing. Yeah.
And so I like that because, you know, the first thing I thought of was, oh, well, you're collecting all the data, so it's your data. You could give it to the government, you could do whatever you want. But I feel like that's a really cool approach, just to say, well, no, you're the fisherman. This is your vessel. You're getting to use the data for your own benefit. This is you're the one doing the work. We're just processing it and then helping make decisions that benefit everybody.
Indeed. Yeah. That's very, very true and very important. It's essential to the whole system. Yeah.
And I mean, there's also like they get to use these data as well, right? So is this question like what's in it for the fishermen? It's not just like the sharing of the data, but for example, I can imagine fuel consumption and stuff like that. Like that would be interest to a fisherman as well.
That's something we said from the start. The first customer is the fisher. It's their data, they're the first customer. And then everything that follows is nice. If we can get information out of that for scientists, he'll be very happy. But the fisherman comes first. And now recently we have the first example where we actually managed to get a company pay for the data, because they are developing this fuel consumption model to allow fishing vessels to plan their fishery and plan their steaming trajectory in a way that it becomes more fuel efficient in the picture of climate change. But for that, they need reliable and high resolution data from these fuel consumption meters. The fuel data that most fishing nations are using in the EU, and I think also outside, is what comes from the books, from the accountancy. We have one data point per year. We have the yearly fuel consumption. So what can you do with that if you want to develop a model that helps fisheries plan their fishery? Now we have it every second for all these fishing vessels. So this is very valuable information, and we managed actually to sell it and give the income to the fisher, and we're very happy that we're able to do that.
To me, this is a really nice example of what the transition from an old system to a new one looks like. As people like Hans and the team behind VISTools, well, they're working on building the basis for this new approach, there is going to be that messy time frame where mistakes will happen. You know, rules have to be tested, new policy needs to be made. And so we need people working on this from the top down as well as from the bottom up. That's the only way we can make transitions like this happen within our lifetime. So if we now look at the VISTools project, I think it makes for a really nice proof of concept of what's possible. So my question then becomes, well, where do we go from here? What needs to change to make this the new reality for sustainable fishing?
I would go for a fisheries management system that is mainly based on what we call the output measures. The only thing we need to know on what is going on at sea with fisheries is the mortality that each individual fishing vessel is causing. So with cameras on board and with the scale and all the data collection we have, we can collect this information. We will know all the different fish species and lengths and invertebrate species that come on board, and we will be able to estimate the mortality for each individual vessel every day of the year. And that's all we need to know to calculate the effect this fishing activity has on the fish stock and the wider ecosystem. With this reliable information, we will be able to give reliable advice. So you get a cycle between fishing industry and fishery science, done by local parties, local scientific institutes and local fishers organizations. So they have to work together, collect the data, process the advice, and so on. Now, what's in it for the fisher? So they will give us all these data, but what is the advantage for them? Well, in the system we are suggesting, if you work with an output management, you can give much more freedom to the fishers on to fish how they want. To my opinion, as a fisher, fish with a mosquito net, or if you want to focus your fishery on small fish entirely and not catch the big fish, it's fine for me. The only thing I need to know is what is the mortality you are causing. If you're catching all these small fish, what is the effect on the fish stock? If you're fishing with a mosquito net and you have all this bycatch, what is the mortality and the effect on the ecosystem and the other fish stocks? You get the freedom to fish however you want. If you want to have 3 types of fishing methods on board of your fishing vessel and switch all the time from one to the other, fine. There's no regulations. There's no need for control and inspection at sea. The only thing we have is a camera looking at the catch. Of course, we will have to develop models, harvest the data, store the data. All these things will cost money as well. But as a system, it will be much cheaper than what we have today. And much more correct, much more reliable. So that's how the loop works at the local side. Now, what is the role of the fisheries managers? The fisheries managers have to listen to the politicians. And as I said in the beginning, what is the role, to my humble opinion, for the politicians? Is not to tell how fishers should fish, but to set the frame. How healthy should our fish stocks be? How intact should our ecosystem be? What is the amount of damage we as a society think is acceptable if we go fishing? Because as soon as you start fishing, you damage the sea. What is acceptable? Then the managers have to watch how all this is going on in reality, have to follow up the fisheries. They don't have to regulate the mesh size. They don't have to regulate which fishing gear you can have on board. No, they have to follow up the state of the fish stocks. They have to follow up the state of the ecosystem. As soon as they notice that the fish stock is going down or the ecosystem gets damaged or there's some sort of issue, they have the power to regulate with simple input measures. Simple things like days at sea, numbers of vessels, things like that. When they see things go wrong, well, they reduce the days at sea, for example. Or they say the fishing fleet has to stay in that season. They should have that power and they should be informed with decent information and correct information. We are in favor of a group of inspectors that actually are present in the auction and in the fishing harbors and have regular meetings with fishers and with vessel owners, show them what the responsibilities are and follow up what's going on. There are, of course, risks if you do that, but there are certainly ways to actually make sure that there's no corruptions. This way of inspecting leads to, let's say, more cooperation, more openness, less distrust, a nicer environment, I would say.
Now, if we really want to go towards this ecosystem approach, as Charlie already questioned earlier in the podcast, we're going to have to work with a whole lot of data and some pretty advanced models. And that is something that the EU has been investing in recent years with what they call the digital twin of the ocean. You can think of this digital twin as a virtual copy of something in the real world. And in this case, it's a high-resolution, multi-dimensional model of the ocean. And it seems that the VISTools project would actually be a really good piece to that whole puzzle.
Our planet is so complex and so difficult to grasp that you actually need these complex models that integrate all this information to come with good predictions or get good evaluations of what we are doing with our planet. If you have a digital twin of the ocean, you have better predictive power for climate change, because what happens in the ocean is so important and related to climate change. But there's also smaller things, for example, predicting algal blooms. In certain circumstances, algae produce in huge numbers, which can, for example, cause toxic areas or areas where there's no more oxygen and so on. You can also start predicting when there will be large numbers of jellyfish arriving on the coast where there's a lot of tourists, for example. And I think the strength of such a digital twin is that it integrates all this huge amount of information. What we are doing is we are using the fantastic databases that the EU has been developing, like Copernicus and EMONTnet, who collect the physical information on the sea and the biological information on the sea, brings it all together in the database. We are cherry-picking the interesting information in this database and adding it to our VISTools model. And as such, we get a digital twin of the fishing vessel and the fishery that describes real-time the activity of the fishing vessel and the fishing fleet and predicts useful information for the fisher themselves, for the scientists, for the manager, and the other users of the sea. We're actually contributing to the digital twin of the ocean.
With this digital twin concept, to me that's fascinating as more of a layman. I just kind of assume that something like that already exists. Like whenever I think of how we have large scale weather models and, you know, climate monitoring satellites and stuff like that, I just sort of assume that, oh, well, obviously we have a huge data set on the ocean and we know what's going on. And the more conversations I have like this, the more I realize how we really don't, how the ocean is sort of this big black box, even today. And so in regards to sustainable fishing specifically, is having this sort of real-time or almost real-time model of either the whole ocean or key areas of the ocean, would that solve the problem, so to speak, of overfishing?
And that will be a very good basis, because the complexity we have in the ocean is so much higher compared to the weather, what you are referring to. In the ocean, you have similar things. It's also the physical things. It's the temperature, it's the currents, it's the salinity. All these things determine what happens in the ocean. But add to that the ecosystem, the living part of it, and all its complexity. Getting a reliable digital twin that predicts everything, this is probably not possible. But we can make big steps. To actually do that, we need these good data, and we are collecting them. And by doing so, we can certainly improve fisheries management by improving the quality of the scientific advice, on the one hand, but also, and not to forget that, is involve the fishing industry, involve them in the whole sustainability story, so that they are motivated to use this information from the digital twin to actually carry out a more sustainable fishery, to become more sustainable by using information on where is the vulnerable fish, where are the threatened species, where should I not go fishing, what to avoid, where are the big concentrations of fish. So all these things, so you have the scientific side, you have the management side, but you also have the fishery side. So this whole digital twin is of value for this whole party. It's very interesting for politicians to actually see and try to simulate what the effects will be of the decisions they take, which today is very difficult. So I think there's so much value in the digital twin of the ocean for all parties involved.
So that begs the question, what is next for VISTools? Where does Hans see, this go from here, and what do they need to actually take the next step?
VISTools as a method, as a technology, is already implemented, and I think that's the nice thing. The whole data collection, the whole working together with fishers and scientists, this is already there. So what we would like to do is a pilot project and see if we can actually make this thing a reality. Because it's not only about collecting data, it's also about predicting fish stocks in the real time. It's also about managing quota and dealing with all these issues that fisheries is facing. And I think the idea of the Belgian fleet is a nice one, because we are a very small fleet. We are active over a very wide region. So nobody sees a problem in the Belgian fleet, I would assume. But then it would also be interesting to do it in a regional scale. And I think the North Sea is a very interesting place to do it. Not only because we have very good scientific knowledge about the marine ecosystem and about the fisheries in the North Sea, but there's also the Brexit story. Why not choose a region where we can actually work together with our British friends and together with our Norwegian friends and come to a more international cooperation that goes beyond the EU and can bring parties more together than they are today.
Big dreams. Big projects.
Life is made of dreams, though.
Hans, what's your favorite fish?
I think my favorite fish is probably the bluefin tuna. I think it's an amazing animal. Imagine you're a herring in a herring school, and you see that school of bluefin tuna approaching you at a speed of 70 kilometers an hour. you're impressed. So that's probably the end of your life as well.
Now, if you are still here and you want to know more about the VISTools project, or you want to get in contact with Hans, I will leave the details down in the show notes. Also, again, a big thanks to ILVO, to VLIS, and of course the UN Ocean Decade, because they're making it possible for us to cover stories like this. And if you click here, you can find the explainer video of our first climate mission. Hope to see you there.